Alright, so we want to evaluate the negative of the square root of 25, if we focus just on the square root of 25, so we've got this here. If we focus just on this, square root of 25 equals 5. So this gets us 5. If we bring down this negative from outside, that's a negative 5, because negative 5 times negative 5 gives us a positive 25. Alright, so for this we want to approximate square root of 72 to the nearest tenth without a calculator. Over here on the right side in red there, I've shown a list of the perfect squares. Like the square root of 1 equals 1, square root of 4 equals 2, and so on down the line until the square root of 81 equals 9. If I look at the square root of 72, that's going to fall in between those two square roots. So if I've got square root of 64 and the square root of 81, well, I know the square root of 72 falls in between there. Okay. Square root of 64 is 8, and the square root of 81 is 9. Therefore, the square root of 72 is going to fall somewhere in between 8 and 9. Now, if I look at how many spaces 72 is from 64, that's 8 spaces. If I look at how far 72 is from 81, that's 9 spaces. So the square root of 72 is like right in the, almost in the middle of 8 and 9, but it's a little bit closer to 8, so I'm going to approximate this at maybe 8.4. Alright, so I'm going to look at the side of the variable here. We have v divided by 3. We want to get v by itself, so we got to undo or do the opposite of what operation is happening to it. Since it's being divided by 3, we're going to want to multiply both sides by 3. Therefore, on the left side you get v. On the right side you have 31 times 3. 31 times 3 is going to equal 93. So there's your solution. So again here, I'm going to look at the equation here and look for the variable, because we want to find out what the y is. We want to get this y by itself, so we have to get rid of this plus 2.75. The opposite of adding 2.75 is to subtract 2.75. But what I do to one side, I've got to do to the other to keep it balanced. And when we do this, we end up with just y on the left, and on the right we end up with negative 6.9. Alright, so if we look at this one here, we've got 3 times w minus 9 equals 12. So we want to get that variable by itself. So I'm going to start by adding 9 on both sides. That gets us 3w equaling 21. Then I still want to continue to get w by itself. It's currently being multiplied by 3, so to undo that, or the opposite of that, is divide by 3. That gets you a 1 on the left. So you have w equaling 21 divided by 3, which is 7. Alright, here on the left side, there are like terms. We have 4k minus 7k. So those can be combined because they're like terms. When you put that together, you get negative 3k. And on the right, we still have that 27. We still want to get k by itself, or all alone isolated on one side. Currently it's being multiplied by negative 3. So the opposite of that is to divide by negative 3, but what you do to one side, you got to do the other to keep it balanced. On the left, negative 3 divided by negative 3 gives you 1, so you have just k on the left. On the right side, we've got 27 divided by negative 3, and that gives us negative 9. Alright, so on here I see on the left side that I've got 9h and negative 2h. I'm going to keep the sign just to the left of it. So I'm going to take this 9h and combine it with negative 2h, because those are like terms. I'm going to put those together. That gets me 7h. I still have the plus 8, and I still have the equals 57. Still going to work to get h all alone by itself on one side, so I have to undo that adding by 8. So I'm going to subtract 8 on both sides. This right here gives me 0, so I'm left with just 7h on the left. On the right, 57 minus 8 is going to give me 49. Still working to get h by itself. It's being multiplied by 7, so the opposite of that is divide by 7. What you do to one side, you got to do the other to keep it balanced. On the left, 7 divided by 7 is 1, leaves me with just h. And 49 divided by 7 is 7. Alright, so here there's parentheses. I'm going to get rid of those parentheses. I'm going to take that 2 outside the parentheses and multiply it by everything on the inside. So we're going to take 2 and multiply it by m, which gives me 2m. Then I got to take that 2, multiply it by that 1, so that gives me 2. I'm going to bring everything else down. So that 5m I'm going to bring down, and it still equals 23. I see here that these are like terms. You have 5m and 2m. That gives you 7m. I'm going to keep everything else the same for the moment. Now we're looking to get this m here by itself, so I have to undo some things. So the opposite of adding by 2 is to subtract by 2, so I'll subtract 2 on both sides. On this side there, it gets me 0, so it leaves me, on the left side, I'm going to put positive 2 and negative 2, it gives me 0. It leaves me with just 7m. On the right side, 23 minus 2 gives me 21. Still want to get m by itself. Currently it's being multiplied by 7. The opposite of that is divide by 7, which you do one side, you got to do the other to keep it balanced. On the left, 7 divided by 7 is 1. Leaves us with 1m on the left side. On the right, we have 21 divided by 7, which gives us 3. Alright, so here we want to look at the output of a function is 4 more. That means addition. So I'm going to be adding 4 and 2 times the input. We don't know what that is, so I'm just going to call that x. So I have 2x plus 4. I know that this should equal negative 10. So now I got a two-step equation here. Once I've got that set up, I want to work to get this x by itself, so I got to undo this adding by 4. So I'll subtract 4 on both sides to keep it balanced. On the left, positive 4 and negative 4 give you 0. So these are with just 2x on the left. On the right, negative 10, negative 4 is negative 14. We want to undo multiplying by 2, so we got to divide by 2, but what you do to one side, got to do the other to keep it balanced. On the left, 2 divided by 2 gives you 1, so you're left with just x on the left. On the right, negative 14 divided by 2 is 7. Alright, so here we have a contractor purchases ceramic tile to model a kitchen floor. Each tile costs $4, and adhesive and grouting material costs $17.82. If the contractor is charged a total of $545.82, how many ceramic tiles did the contractor purchase? Well, we don't know the tiles, but we know they're $4 each. So we have 4 times however many there are of them. We also know that they pay $17.82 for grouting material and adhesive, and the total for that equals $545.82. So we're going to work to try to get the x by itself. So I'm going to subtract 1782 from each side. On the left, when you put those together, that gives you 0, so you're left with just 4x remaining on the left. On the right, when you subtract those two, we end up getting 528. We want to still get this x by itself, so we've got to undo the multiplying by 4, which is the divide by 4, which you do one side, you got to do the other to keep it balanced. 4 divided by 4 is 1, so that we're left with just 1x on the left. And on the right, that ends up giving us 132 tiles that the contractor can purchase.